I need to find the absolute minimum value of a polynomial function over a closed interval, and polynomial functions are continuous and differentiable. I take the derivative and I get a second degree polynomial, which I can pretty nicely factor out of 6 and then factor the remainder into two linear factors. And the solutions are then positive 1/2 and negative 1 for the critical numbers of G. To save myself the time of having to find the y values of every single critical number and every single endpoint, I took a quick look at where is the derivative positive and negative. So if I go positive slope, positive slope, the only possibility of an absolute minimum is at the left endpoint and at this relative minimum of 1/2. So those are the only x coordinates that I look at. What are the y values? I have found that if I'm without calculator and I need to quickly do a polynomial, plug a number into a polynomial, that often factoring out the x squared of these leading terms, or these two highest degree terms, just makes the arithmetic end up being a lot easier to deal with. When I plug in the -2, I know that I square -2 to get 4, and then -8 plus 3 is -5, and so on, and the arithmetic isn't too bad. Even when I'm putting in a fraction, I square it to get 1/4. 4 times 1/2 gives me 2 plus 3 is 5, and so on, and the arithmetic again isn't too bad. I wanted the absolute minimum, and I can see that -7 is smaller than -3/4. That is the minimum value. The answer to an absolute extrema is always just the y coordinate, the y value. In the minimum case, the lowest value in the range of the function. So the answer is A.